All right, let's take a look at the very last example. You have a bearing word problem, and of course it's given in the context of vectors. Okay, so it's not too bad if you look at this problem here. It says an airplane leaves the airport at a bearing of 45 degrees, traveling at 400 miles per hour. Okay, so I have some kind of airplane, 45 degrees, roughly, something like this, right? There's 45 degrees from north, and the magnitude of this is 400 mph, okay, miles per hour. All right, you have a wind that's blowing at a bearing of 135 degrees. So the wind, right, I'm just going to put, I'm going to make sure everything is in component form. So at the origin, if I were to draw an angle that's 135, it would look something like this. But the bearing or the speed is only 40. Okay, so draw this vector a little bit smaller. So this is 135, right? And this guy right here is only 40 mph. Okay, so this is my plane right here. And this guy right here is my wind. Okay, so the question is, what is the actual direction of the velocity of the plane? So the actual direction and the velocity of the plane, right, is basically adding this vector right here of the plane and adding this vector of the wind. So if I say, hey, draw the resultant, well, how would you draw the resultant, right? I would transfer this wind right here, this vector down here, and put it over here, right, tip to tail, and the resultant will be the distance from here to here, right? This is what they want you to find. Okay, so this is the actual direction. Maybe we'll call it R. Okay, so let's draw in some angles. We know that if this angle right here is 45, right, this angle right here will be 45 by alternate interior. And we know from here to here is 135. This right here is 45, right? And so what you have right here is a 90-degree angle. If this is 45, this is 45. And so to find R, right, it's simply, 40 squared. This right here is 40. And this guy right here, this dashed line is 400, is the square root of 400 squared plus 40 squared. And if you enter that in your calculator, about 401.99 miles per hour. Okay, so that would be the resultant. If you think about it, right, if the plane is going this way, but the wind is blowing this way, right, the resultant, it's going to be blown slightly off course, right, by the wind. Okay, so that's the resultant. And then part B is actually asking you for the direction, right? And the direction, right, if we're talking about bearings, we need to know what this angle is right here, theta. And the direction would actually be the angle from here to here, right? This is what we need. Okay, so once we figure out if from here to here is 45 degrees, right? And from here to here is theta, we'll just do 45 minus theta to give us question mark. Okay, so question mark is 45 degrees minus theta, and that will give you the direction. Okay, so quite simply, right, we're just going to use our tangent function. Tangent of theta, right, is equal to opposite over adjacent. So the opposite side is 40. The adjacent side is 400. And if you take the tan inverse of 40 over 400, or 1 over 10, you're going to get approximately 5.71 degrees. Now, that's not the actual bearing, right? Because we want to figure out what question mark is. Question mark is from here to here is 45, from here to here is theta. 45 minus theta will give you question mark. So 45 minus 5.71, approximately 39.29 degrees. You don't need to write north, right? You could just say 39.29 because that's assumed from north. And that's pretty much it for your bearing word problem. Again, it's applying the usage of vectors this time. Again, seeing this dashed line as a resultant, right? If a plane's going this way, the wind's kind of pushing it more towards the the north, and of course you're being asked to apply your vector skills on this particular problem. But really it's just Pythagorean theorem and a little bit of SOHCAHTOA.